D.
D. Sacrilege. What's up, you scholars of enlightenment? Dr. Sam Gregson, particle physicist here again. I hope you had a brilliant weekend and are enjoying a fantastic start to the week. What is the greatest physics meme? I'm sure you have your favourite. Today, I've brought together 3 fantastic scientists and science communicators from the worlds of particle physics and astronomy. They have in turn provided their favourite physics memes, and tonight we will assess those memes, rank them, and determine the greatest physics meme ever within the realms of space science and particle physics / quantum mechanics. This ranking is entirely subjective. It's only our opinion on the day. So if you have your favourite space or particle physics meme, please drop it in the comment section below, and maybe we'll end up discussing it in a follow-up. The meme wars are never over. To join me in this titanic struggle between 2 subject fields, I'm joined by 3 phenomenal special guests. Firstly, for the space scientists, I'm joined by Dr. Maggie Lieu. Dr. Lieu is currently a research fellow of machine learning and cosmology at the University of Nottingham. Prior to this, she held a research fellowship at the European Space Agency, based at the European Space Astronomy Centre in Madrid, where she worked on projects in preparation for Euclid, the space-based optical / infrared telescope launched in 2023. Euclid's scientific goal is to map the dark universe and help us to learn more about the nature of dark matter and dark energy. Maggie also has a fantastic YouTube channel where she goes under the name Space Mog and discusses all things space and cosmology. Also in the Space Corner is soon-to-be Dr. Jasmine Singh. Jasmine is a graduate student in the University of Texas at San Antonio SWRI Space Physics program. Her research focuses on planetary science with a special focus on Europa. She's also a passionate science communicator and has a fantastic Twitter profile called Asteroid, where she regularly shares the wonders of space and astronomy. In her own words, she loves screaming about space. Batting for us particle physicists, I'm joined by Professor Clara Nellist. Professor Nellist is a particle physicist and science communicator with extensive experience. Currently, she serves as an assistant professor at the University of Amsterdam, and her research focuses on investigating the top quark with the Atlas experiment, as well as exploring dark matter through machine learning algorithms. Dr. Nellist also has phenomenal TikTok and Instagram accounts where she explains particle physics and brings audiences up-to-date news from CERN and the Large Hadron Collider. All the social media links for my guests are down in the description. So I really couldn't hope for a better set of special guests for this battle of the physics memes. Before we dive into this ranking proper, I want to ask you all, what will you be looking for in an S-tier physics meme? What are your criteria for greatness? So Maggie, maybe if I come to you first, what are we looking for here in a brilliant meme?
I mean, for me, it's just something that I would share, and I don't share many things. So
Right.
if it's like, if I would share that with someone, that's an S tier.
Right. Good. Clara?
Yeah, for me, I've got to, the science has to be right. It has to not annoy me by being incorrect. And it has to have layers to it. I want both pop culture and science. I want to feel connected to it.
I was going to say, for me, I really like it when when a meme subverts a common meme structure and uses it for science. So I do like that mixture with the pop culture and the science. Also, obviously, good if it's correct. And I don't mind, probably goes with my sense of humor, but a little bit of edginess, not too much, but, a little bit of spice in there can help. So, okay. So there are our criteria. So let's jump into our memes. So Clara, I came to Maggie first last time, so let's go to you first. You're coming in strong with this one. Why are we, I very much enjoyed this one. So what are we talking here?
Yeah, so a lot of people, when they come and visit CERN for the first time, they are surprised that our buildings are not the fanciest. I think if you've grown up with sci-fi and you turn up to some, here we're looking at one of the buildings. If you turn up to some really high-tech science lab, you're expecting shiny silver with lots of glass and LED lights, and people come to CERN and see a bunker and wonder if they're in the right place. And what we have to tell them is that we spent all of our money either underground or in one of the other experiments, and we don't spend money on making our buildings look fancy.
So there's this phenomenal disparity, as the meme kind of says, we're going to go back to it in a second, between these beautiful detectors here for CMS, for example, Atlas as well, and then what looks like some sort of dilapidated 1960s asbestos-riddled shack, right? This is the kind of idea of what's going on here.
And you'll also probably remember even the building numbers are very confusing.
Yeah.
So the numbering of the buildings does not make sense when you first get there. And if you're trying to find a specific building, good luck.
Are they based on when they were built? I forget, because they've kind of just filled in all over the place, right? So you never know where you go. And I think when we were there together, at least like 10 years ago, you're still there. There wasn't an online portal for finding the buildings, so it was incredibly difficult to know where you were going, like at any time.
Yeah, there's a digital map now, which helps quite a lot. But the way that they did the numbering, if I remember rightly, is that each batch of numbers is a different building type, and then they go sequentially down those numbers. And then wherever they were built on the site, it just gets the next number. So they're not where you think they're going to be.
Is that the same for like every physics building ever? Because at the University of Nottingham, also, there's no maps to be found anywhere. No one can find the numbers of the rooms. They're not in order, but you can find them on Google Maps, surprisingly. Like you can zoom into Google Maps and find it, but in the actual buildings, you'll have no idea where you're going unless you've been there before.
I will say, I don't know who's been to the Cavendish in Cambridge recently as well, but this is also a kind of 1950s, 1960s asbestos riddled shack, or was at least when I was there sort of 10 years ago. So seems to be a little bit of a theme, kind of form over function, maybe. Maybe we're saving our money for the important stuff. So SpongeBob as well, or am I messing it up in the meme?
I think it's SpongeBob. It looks like it, but it's not any episode I recognize. Not that I'm I haven't watched them all. Yeah.
Right. So Maggie, we'll go to you. What are we going for on a rating? So we've got our standard rating procedure. We've got S, which is our best one, specials, A, B, C, D. What are we thinking for Clara's opening salvo for particle physics, which is CERN experiments, CERN buildings?
I'm going to go quite low for you. Sorry, Clara.
This is
because I would not have got this until you explained it in detail. If I saw this, I'd just be like, okay.
So maybe a bit more of an intelligence. So I very much enjoyed it. So I was going to go A for this, but maybe this shows the disconnect between the particle physicists and people outside. So if you're going, what are you going for, Maggie? C were you going for?
I would go for a C.
So I'm going for A. Clara, you can mark your own as well. What we thinking?
Yeah, I mean, I was going to put it in the middle. Like, I'm happy if it lands as a B. I realize this is a very niche joke, but I also want people to be aware that when they turn up, not to judge us too much by the buildings. Although we do have a very nice new museum that does look very pretty, so that's kind of spoiling them.
That is true. They've kind of slapped on this modern futuristic building on the front recently. I think we've been very good there. We worked together. We got to a B. So good stuff. Right, let's jump into one of Maggie's. So Maggie, Clara, you get a chance to fire back straight away. So Maggie, talk us through this one. I very much enjoyed this one, but maybe it's a little bit spicy.
Can you see all of that?
You can when I scroll in a minute. So do you want to talk us through, and I will scroll for you.
So this is like the fabric of space-time, like that grid, and mass warps space-time. So you've got the sun. It makes a small dent in the fabric of space-time. It's a little bit heavy. You've got neutron stars, which are a lot more heavier. And then you've got black holes, which technically are a singularity. So you'd expect it to go all the way down, and it doesn't quite do that. But the thing that does do that is the thing at the bottom, which is... I just thought that was funny. Yeah,
my lady friend Sophie thought this was funny as well. Clara, thoughts?
I mean, it's a classic.
It is classic.
It's no longer I'm not judging, but it's no longer my immediate sense of humor, but I think it is a classic. So
we have to be a little bit careful in physics, not putting people off, and I understand that. But I did enjoy it, did bring it to, and I did enjoy that subversion of a common joke scheme with it as well. So Clara, do you want to give an initial score? We'll try and rattle through these a bit.
I mean, there's the science is pretty solid.
Yeah.
So it's teaching you something in the meme as well.
Yeah.
Yeah, I'd land it at a B as well.
Land it as a B. Yeah. I might go for an A. I did enjoy it. A little bit of spice, like I said. I like the subversion of a common joke format, and the science is good. So Maggie, you get to mark your own.
I would give it an A.
Okay.
I thought that was funny.
All right, good.
I would share that.
Okay, fair enough. So Clara, unfortunately, you've been outvoted up to an A. Happy with that? We're happy with that. All right, good stuff. Now, Jasmine has not been able to join us today, but I'm going to throw one of hers in, and we're going to do hers quickly as well. So, Maggie, I'm going to throw it to you because you're our space expert. So, where are we going here?
So everyone knows like that the Earth is flat, right?
Apparently, I've been told this a lot.
Yeah, so we look around, and all the other planets are round, but we're flat, so we're square. It's kind of awkward.
But I mean, God just made us so special and anthropocentric, right?
Of course.
So it doesn't make much sense. Clara, thoughts?
I think this is a great one.
I do enjoy this, to be honest. This just really points out the absurdity of the situation in a very, very simple way and easy to grasp. Clara, you want to give a score?
Yeah, I mean, I would put this one either as an A or maybe even an S. I think this is I would share this one too. Yeah,
I'm going to go for an A. I've seen this one around and I do enjoy this. So you get the deciding vote, Maggie. You're probably going to upvote the space ones here. S or A here?
I'll go for an S too.
You're going to go for an S. Our first S of the day. You would definitely share this. So that's getting this Maggie seal of approval as well. Okay, excellent. Right, now I get to be embarrassed and put mine forward. So my first one, I've gone with the strong quantum theme in mind. So fundamental probabilistic nature of quantum mechanical phenomena. So here we have the situation of the double slit experiment. If we are not observing which slit the particles go through, then we seem to get this interference pattern. If we do observe, they seem to go through a particular slit. So when we don't observe, we can't really work out which one they went through, and they make this nice interference pattern. But when we do observe which slit they go through, they seem to go through a particular slit. There's a nice version of this one. I saw the chap in the factory watching them all come off. I don't know if you caught that version. And when he stood there, they're all the second version. When he's not, they're all when he's watching, they're all the first version. When he's not, they're all the second version. I might clip it in. Thoughts on this one? I'll go Maggie first.
I like this one. I think most people will get it, but I don't know actually how many people actually.
I feel like double slit a lot of people get, even though maybe they don't have the full
primary school. No, secondary school, right? You do this.
Maybe like right at the end now of physics, you sort of do a little bit of like rotating phases and interference and this kind of thing. Very, very basic level though in high school, or at least when I did it, but I'm old, so maybe they do more of it now.
But I like the monkey as well. Is it a monkey even?
I think so.
That's like a common meme that's used in other things as well, because I quite like that as well.
Where are we going for a score?
I'll go for an A.
Going for an A. Clara?
Yeah, I'm happy with an A. I will warn you, I should have said this right at the beginning. I'm quite a nice grader. I don't know if my students would agree, but
you're a friendly grader, so we're not going to see many C's and D's. There's also a little bit of kind of social fear here, isn't it? I don't want to be too horrible at your memes that you enjoy, but don't worry, mark them harshly if you want. I'm happy with an A. I think that's
I think this one's a solid one as well, and I think even so, it is taught in schools, and even if it isn't, I think it's quite a common concept that's shared around a lot.
It's one of those like massive experiments that people have. Almost there's like a kind of crossover into popular culture of it, even if people don't really exactly understand what's going on. They're like, oh yeah, double slit, that's a quantum mechanics thing, right? So people have an awareness of it, even if they don't get it.
Can we ask some like people if they've actually heard of that before? Because like I bet like a lot of people haven't.
Right, down in the comment section, if you put I'm talking out of my backside that nobody's ever heard of this, we want to know.
do a poll.
We will. So, straw poll below. Have you heard of the double slit experiment? Yes or no? That's going to be the pinned comment. Good. Right, Maggie, you're up again. Was it Maggie who went first? I think it. Or was it Clara who went first? Clara went first. Right, we're back to Clara. Right, Clara. When someone asks you why you keep making references to obscure particle physics and mathematical gauge theory, it defines who I am. Now, I feel this one in my bones, but Clara, what we thinking here?
Yeah, I think I have a tendency to keep chatting about science whenever anybody brings it. If somebody at a party says, "Oh, I hear you're a scientist," I'm like, "Let me."
Are you that one in the corner of the room who's like, they don't know I'm an LHC particle physicist? You know the one?
Yeah, but no, because I've told everyone.
They definitely don't. Okay, everyone in the room now. It's like the inverse, dark version of that. Okay, good stuff. Maggie, what we thinking?
Again, like, I feel like Clara's gone for the very niche memes that no one will know anything about, like gauge theory. As soon as I hear that, I'm like
a bit scared.
Yeah, let's hide away from the gauge theory.
See, this is another one where I really enjoy it because, you know, I feel like I'm in that group who enjoys that, but I appreciate maybe in terms of memes and a bit of wider participation, maybe a little bit lower. Where are we going, Maggie?
I'm gonna say C again. I might even push D.
Okay, so we're getting mean now after we said we're going to be nice. I'm gonna go
gloves
C.
Are off.
Yeah, exactly. I'm gonna go C, not because I personally enjoy it, but I know that it's slightly niche as well. Now I do enjoy a niche meme, but maybe if we're talking for a wider audience, maybe in the C. Clara, thoughts?
Yeah, I'm happy. You can downvote me. I think a lot of mine are quite niche. I picked ones that I would share, and I'm in a very big in a bubble. So
you see, this was very good because you sent me them this afternoon, and I was laughing and really happy, and then I realised that like most people won't get them, but there's also a bit of a joy in that as well. When you're like, yeah, I know a lot of people won't get this, but I really like it. That's that can be a different way of enjoying them, right? So. Yeah. Clara, sorry.
Well, I was going to say my favorite thing about memes, and then also when they extend to videos as well, is that you should get half the joke, because a lot of the times the meme is a very well used format.
Yeah.
And so then it's a way to connect with people that maybe don't fully understand all of the science, but then they'll get it from the context of the meme. But then maybe I picked also quite niche formats as well.
No, it's a very good point, and that's why I really like this format as well. Like you say, because you can kind of meet people halfway, right? If they enjoy SpongeBob or they enjoy a good meme or a good joke, you can kind of maybe draw them in and reach different audiences. So it's a really nice.
I should also say I'm like the kind of person who doesn't like stand-up comedy because I never get the joke.
What was that? I can't remember. The first thing I said to you, Maggie, about there was some video that I wanted to do, and it was something you thought I wanted you to come on and do stand-up comedy, and I think you kind of were absolutely terrified when I said like, I'm a science communicator and comedian or something. You were like, I'm terrified. Even though I didn't want you to do that, but I think you were like, yes. All right.
This guy?
Good. Yeah, exactly. Who is this crazy weirdo who's just messaged me out of nowhere? Exactly. Right. So Maggie's up for the second one. Talk us through this one, Maggie.
So this goes back a long time. Like everyone who does anything will put a banana for reference for size. And there's a banana in this image, but this galaxy is so large you can't see the banana.
We usually do more about neutrinos with bananas, right, Clara? This is when we see bananas, we start thinking about neutrinos.
Yeah, because they make
was it potassium? Some radionucleotide of potassium in them is radioactive and puts out.
Well, they put positrons out, and so then you get annihilation.
Right.
Wait, so, bananas emit positrons.
Mm-hmm.
Yeah. So then you get a little bit irradiated by your banana. I think it's usually on like any like radiation chart is like, you know, high altitude flight, visit to the hospital, background radiation, like buying a bunch of bananas from Sainsbury's or something. It's always on there somewhere.
The banana radiation scale.
Yeah, it's on there.
Yeah.
So we maybe get a little bit different with this, but I do enjoy the joke here. Good science here, because obviously there's an idea of scale, Although there's a lot of things that wouldn't show up in this picture, I guess. Clara, thoughts?
I like it. I would have put Wales, but I realise that's a very UK.
The country or the animal?
The country Wales is often used, and then I think in the US, I think they use Texas quite a lot for scale. You still wouldn't see it, right? So it's still the same joke.
Yeah. Where are we going for a score?
I'm first for the score.
You are this time.
I would put it as like a B or a C. I think it's good, but
not that good.
I think it's nice. It doesn't make me laugh. It makes me think.
Okay. So B, I'm happy with the B as well. Maggie, thoughts?
I'll put a B too.
We're happy with a B here. So decent science, makes us think a little bit. Good. Right. Jasmine's second one, I'm going to bring her in, was this one. Maggie, I'm sure you can explain this one for us. Jasmine, I like Jasmine's. They're a bit more playful, a bit more friendly, a bit more, I don't know, upbeat. What we dealing with here in terms of the science?
I don't get jokes, so I'm probably interpreting this wrong. But okay. Basically, Jupiter's the biggest planet in our solar system, and it acts kind of like a defense mechanism, and it drags like a lot. If asteroids are kind of, well, most asteroids are in the asteroid belt, but if there was something coming into the solar system, it's likely to be pulled by Jupiter's gravity rather than like coming straight at us. Maybe.
That's how I read
nodding
it.
As well, so.
That's how I read it, and also maybe that it has the most moons, so it grabs a few and has the most moons as well. Maybe you could read it like that if you wanted to as well. So maybe a couple of lines of science in there. Nice, cute kind of little picture and gets that kind of idea across. Clara, thoughts?
Yeah, I think this one is very cute. I nearly sent you one of the same theme, but it was way too niche because it was very LHC technical specific. And I was like, I'm going to get in trouble for this.
Was it like dark matter annihilation on the far side of Jupiter or something? What was it?
No, it was LHC magnets quench. And then it was the beam dump at the bottom saying, is this for me?
I've got you.
That's I think Maggie would have been mad at that. I didn't send that one.
Maggie would have lost it at that one.
But this one has a cute Jupiter, so I like it.
I do. The eyes are kind of cheating us up to where are you going for scores?
I'm going to go D on this one because I don't get it.
You're a space expert and you didn't get it. Okay, fine, good. Down at a D, fine. Clara?
I mean, I was going to give it a B, so I'm happy for it to be somewhere in the middle.
All right, I'm happy for it to be somewhere in the middle then. Let's go for a C. The eyes have dragged it up from a D. Fine. Right, good stuff. I'll go for my second one. Now, I put this one in. I hate this one, right? I know it's supposed to be our favourites, but it is a very popular one in particle physics. So this one. So just one more collider, bro. I promise, bro. Just one more collider and we'll find all the particles, bro, etc., etc. Keeps going. Basically the same. $22 billion and we'll solve all the problems in physics. So this is the particle physics contrarians. Why are you spending $22 billion? Because certain people, we won't name any particular individuals, but maybe certain influencers have convinced them that particle physics is kind of dying, which is not really true. There's lots of things we want to do, particularly in precision Higgs physics with Future Circular Collider and a Higgs factory. So I don't like this one at all because it's I feel kind of attacked by it. And I guess you do as well, Clara. I don't want to put words in your mouth. But also we don't only want one. We probably want a Higgs factory and then a FCCHH or a muon collider. So it's kind of wrong in the physics as well. Like, although maybe the theme remains accurate.
Why does it always say bro? Is that a thing that particle physicists say?
No, I just think it's kind of saying that people are asking for something stupid, like, bro, please, come on. It's like a begging kind of wording, I guess. We're begging. We don't have a good reason to do this, so we're begging for the money. Clara, do you want to add anything to that? It kind of makes me uncomfortable, this one.
I mean, I don't like it either because it's as you say, it's not we're not doing it for no reason. Right now, we, as a whole particle physics community and even broader community, we're having huge discussions about which future collider could possibly be the right option, and we don't take these decisions lightly. So yeah, as you see, I get I'm like, let me explain to you why this is wrong.
No, it's all right. Don't worry, because I know the common theme that's out there. Is that, you know, we just want to keep our cushy jobs. How many like extremely wealthy particle physicists do you know? I don't think it's a cushy job. I think it's a hell of a hard job with lots of hours, and a lot of people do it because they're really interested in working out the best way to understand the universe better. And as you say, at the moment, there's massive discussions about the best way to go with this. So I'm happy, Clara, if you were as well, to throw this into a D, into the room 101, if you will. Maggie, do you want to save it? Or will you let us have our little moment?
This. I don't get this.
Good.
Like,
good.
I will say it does also inspire me that we need to, you know, communicate better why we want the next future collider. So I'm not massively offended by the fact that it also tells us that we need to do a better job explaining it. But yeah, I think we're not doing it for the sake of it. And also, as you say, like, I could earn 3 times more money being in finance, so I'm not doing it for the cushy.
Exactly. It's actually a really excellent point that you make as well. So check back in on Friday when you will have a video on the mapping of the Higgs potential to annoy Sabine Hossenfelder. So that will be my video on Friday. Good. You gave me a chance to peddle my wares. That's good. Right. So where are we now? Clara is back. So Clara, you did get your magnet quenching in, even though you maybe not in the format that you initially expected. Talk us through this one.
So yeah, this one I have to explain it, so then that means it's not a good joke, but it makes me laugh.
It's got words on it as well, so we've got immediate problems here. But yes, go on, please.
So when we have the superconducting magnets around the LHC, they are superconducting, which means that they have 0 resistance in them when they're cooled to a very low temperature. But what can sometimes happen is that they quench where the superconducting properties break down. And when that happens, we have to get the LHC beam out of the LHC tunnel as quickly as possible. Otherwise, it will damage our machine. Like, that's the only risk, is that it breaks our machine. And so this meme is I must get out of here as quick as possible. And so it's playing on the fact that
So I don't think people know as well. We have these like essentially huge beam dumps, right? Big blocks of graphite where we basically send all these protons and they just kind of go off tangentially out of the machine and smash into a big block of graphite as quickly as possible before they drift against the walls and potentially cause damage to the machine.
Yeah, one of my favorite facts is that we have the LHC, the protons are in bunches and they're in a train, so you can think like an actual physical train, and then at the front and the back, because it's in a circle, there is a gap between them, and that gap is exactly the amount of time it takes to remove the beams from the LHC. So you have to keep that gap in there so that we can cleanly remove the beams.
Like it. So we're teaching as well. Excellent. Good stuff. Maggie, where are we at?
I didn't get it, but Clara explained it really well, and I feel like I learned something now, and I want to learn more. I want to know, like, why does it quench, like, and all sorts of things.
And really, isn't that what it's all about, Maggie? That you want to learn more? That's the key, isn't it? So
no, it's not.
No, it's not. All right, fine, good. All right, I tried, Clara.
I'll go for a B though.
You go for a B. I'm happy with a B, Clara.
I mean, I think that's generous because it's quite niche, but I'm also going to accept it.
All right, good. Well, we take what we can get. Good.
Yeah,
we'll take what we can get. Right, good stuff. Maggie, you're back in. So where are we? Here we are. So is that you? Yeah, but that's an old photo. To talk us through this one.
So this is the idea that the universe is really, really big, and the fastest that anything can move is light, which is the speed of light. So the galaxies that we're actually looking at are like emitted a really, really long time ago. Yeah. Essentially, because of the distances they take to reach us, basically. So that's a really old photo. We're not seeing it as it is in this moment. We might be seeing galaxies that are already like dead.
Good stuff. Clara, there's a good bit of science in there.
Yeah, I like it. I must admit, the first time when you brought it up on screen, my first thought was, oh, was this taken with a previous telescope and we've got a better version?
Yeah.
And then also as Maggie was explaining it, I remembered.
So we got the same problem flipped over then. So where are we going?
It says in like particle physics, quite often you break the speed of light, right?
We've never actually done it. There was a lot of big news about it potentially happening, but it was because of a loose cable. So
I remember that. That was when I was knocking about there. So yeah, there was a neutrino beam was sent from CERN to Gran Sasso, and they thought the neutrinos were traveling faster than the speed of light. They tried to fix all the systematics in their experiment. They couldn't. They sat on it for a long time, and then they thought they had to put out their results. And then eventually they worked out that there was a loose cable in their machine. So sadly, we've not broken the speed of light. Unfortunately, we keep trying. We live in hope, but no. Yes. So I also thought maybe this was another telescope as well. So maybe there's a problem with multiple interpretations here, but I did enjoy the science. It does make sense. And Maggie explained it nicely. I'm going with a C. Clara?
Yeah, I mean, we can put it as a C. I was going to go with a B. I was also thinking that my first interpretation, if you were then going to see the new galaxy, it would look better, which is usually the wrong way around, like on a dating app. Well, not always, some people age beautifully, but usually people use older pictures because they think they look better then.
I see. Yeah.
So, yeah.
So you might have expected it. Yeah. So it kind of maybe doesn't work slightly. Okay. Maggie.
Yeah,
sorry, Clara.
Oh, no, I'm happy. I would have put it maybe as a B.
Maggie.
I'm happy with the C as well.
You're
I feel like I needed quite a bit of explaining for that. And yeah.
But you would have shared it. So surely it's an S.
Maybe I would have shared it.
Okay. Good stuff. Right. What's Jasmine got for us next? So what happens in a black hole stays in a black hole. Do you want to talk us through this one, Maggie? I think it's probably fairly self-explanatory.
Yeah, nothing can escape the horizon of a black hole. So whatever you do in there,
I guess it plays on the common trope of what happens somewhere stays there if people get up to no good and they don't want other people to find out. Clara, thoughts?
I think it's a great joke. My only complaint is we've got really great photos of black holes and they're not using that.
And they've not used the good. They've not used the good one. They've used the interstellar one. Yeah.
But maybe that's less. I mean, no, I'm going to insult colleagues if I say that. I'm going to say maybe it's slightly less recognizable, but it shouldn't be. Everybody should see that photo. It's incredible.
Is this the Sagittarius A star one or the M6? Is it M6? I forget the.
Yeah, we have more now, but the original also was. I mean, it was incredible that they managed to get the photo, but no, the joke here is solid though.
I agreed. I like the joke. Yeah, they should probably have the better photo. Agreed with that. Subverts a common joke style. I kind of like it. So, Clara, what we thinking?
Yeah, I would put this as an A.
I'm happy with an A. What are you thinking, Maggie?
I thought it was a bit boring, to be honest.
Okay, that's all right. I like that you're not being like led by the arm with the A. I'll just say A as well. This is good. So, what are we saying? C. So 2 A's and a C. So we're between B and A. What should we do? Whoever says it first is probably going to get it. B.
You're the
B for black hole.
Adjudicator.
All right, B for black hole. I'll make the hard choice. Good stuff. So that was Jazz, and then I'm up again. Brilliant. Good. So I'm going to get abuse. Okay, I like this one. I'm just going to say this. So common meme format. Obviously, we have the I don't know, what would we call it? The other girl meme format. So we have the chap who is the observer in quantum mechanics, and he's looking at the system. Now, a quantum mechanical system is made up of a number of states. However, when you make an observation, you collapse the wave function into one of those particular states. So I know I'm in, energy level number 1. I'm not in energy level 2, 3, 4, 5, or 6. But before I make the observation, there's a probability of being in all of those individual states. So here the observer has made an observation and that pushes them into the observed quantum state, and all the others are just watching, saying, well, you're not in me. So sorry, that sounded so bad. You're not in this particular state. So Clara, thoughts here?
I think this is great. Very I mean, this format is
Very
one
well
of the
known.
most famous.
Yeah.
And to be able to make a change with that and make a new joke is very good.
Maggie, the harsh critic.
This is like beyond me. Like
beyond. So you're going to be harsh then. So what are we thinking?
D.
Sacrilege. Okay, so Clara, what were you going to put?
I was going to give it a B. I thought this was quite a good
okay,
a good joke.
Well, I was going hard with an S. So what have we got? D, B, and S. So they're nicely spread out. So I guess this one gets a strong B. Holds a strong B. Where is it? Good. All right. Well, that's my shot. Good. Right. So where are we? We're back to Clara. Good stuff. We're flying through these. So where are we? Talk us through this one, Clara.
Yeah, I don't actually know where this picture is from. I just really liked the Stegosaurus head. Also, I don't think the science is great, but again, I just like the Stegosaurus head.
That's one way to go. Well, let's take this as a, what is it? What do we call it? A teachable moment? What are we saying here with the science then?
Well, it's saying the problem of traveling at 99 point by the speed of light is that you can only live in darkness, but at that speed, light would still bounce around, so you wouldn't be living in darkness.
Yeah, the speed in the frame would still be the same, right? So are we worried about accuracy here, but we like the Stegosaurus head?
That was pretty much what I was going for.
All right. So
Clara likes cute things. So if anyone wants to make memes for Clara, just make it cute.
And have a Stegosaurus in there. Stegosaurus is a top tier dinosaur, to be fair. So I agree with that.
Also, it's spooky season, and this was quite like a dark meme.
There is a bit of, we got the sort of clouds coming in the background, bit of Stranger Things vibe. What are we thinking, Maggie?
D.
I'll go with D only because I'm not sure about the science, but I'm probably just missing something, so I'll go with a D. Clara,
I'm happy for it to go with D. I didn't agree with the science, but I wanted the Stegosaurus.
Fine. So we've smuggled in the Stegosaurus. I'm happy with that. Good. Maggie, right, where we at? So here, I don't know if this one showed up right, but you can tell me if it did or did not.
I don't know. I just found that online, but essentially, when you divide anything by 0, it's essentially infinity, right? Or
things
like
start going wrong. Yeah,
like a black hole. I'm not even sure that is a black hole as well. And I think Clara's previous comment about we have so many good pictures of black holes probably stands here too.
Clara's limbering up. I can see she's ready. She's ready for this one.
She's like, what is this?
Clara, go in on this one, please.
Well, I'm trying to think about it because the pictures that we have are orange from the light that comes to it, but that could just be in astronomy, often things are shifted in wavelength to look pretty. So I don't know whether actually, maybe they are blue.
But I feel like this one was done on some sort of, word art sort of 1990s type of dealio, which is, I think you're trying to help it, but maybe it doesn't deserve it. I don't know. Just my thought.
It made me laugh, but I don't know if I'd share it.
Okay.
So the images that we have of black holes are like taken in radio data.
Yeah.
So that's like
so they're false cover. They're false color anyway. So
yeah, so they're not real colors. But I think you can imagine so supermassive black holes have accretion disks, and it's made out of like gas and dust. And gas and dust tend to scatter blue light, so they appear red. And then you have the jets, which tend to be very energetic, and you could imagine to be quite blue or white. But yeah, the discs would be quite red.
What I'm enjoying here is that you're explaining really nice science, but you can't save it. You're trying.
I'm not. I don't.
It's good. And I'm enjoying it, and people are learning stuff, and that's fantastic. But I don't think I'm going to let you off. Clara, thoughts?
Yeah, I enjoyed the explanation, but I
Good.
also think we need a astronomy one in the bottom.
Agreed. I'll take that. Any closing arguments to save you from holding a strong D here, Maggie?
No.
Okay, good. We'll
I'm not going to put in the effort.
Not gonna put in the effort when the jury's already decided. Good. Right. Excellent. So where did Jasmine go now? Ah, nice. Because I think there's more on this recently, Maggie. You will know. So an asteroid just minding its own business. Very common meme format. A giant piece of metal made by humans. So what's the experiment we're discussing here?
I think it might be the asteroid where we crashed into it just for the sake of crashing into it.
So this is DART. Now, I want to show you something that I noticed today when I went looking for DART. So they've got this. I don't know if either of you have seen this, but when you look for DART, they have this nice thing comes across and then knocks over which I found really nice. I was like, I didn't know that they had that going on, which is quite cool. I know Google does these things from time to time. But yeah, this is DART. So the double asteroid redirection test, which hit this asteroid Dimorphos and changed its period and its orbit around this asteroid Didymos. And they're trying to work out how much that was changed based on the impact of this DART spacecraft. So, and I think they've sent the follow-up. Is it Hera? I think they've sent it very recently to kind of do some follow-up and look at the size of the crater. So, Maggie, thoughts about this one? Very common meme format. I do like the subversion here, but maybe a little bit niche for people to understand without kind of DART being maybe overlaid here.
Yeah, and I'm not sure it is a common meme format. I haven't seen this meme
You've not seen this
before.
one too much.
No. Have you, Clara?
I have seen it for some other things. I'm overthinking it because I'm like, well, this school truck is getting in the way of the train, not the train.
You just made it like 1,000 times darker than I thought. Like, why are they throwing the school bus in front of this train on what seems like a completely empty road? That has just completely changed my view of this one.
At least it looks empty. So
it does look fairly empty.
Yeah.
But, what are we thinking in terms of score?
I would maybe give it a C. Like, I really like the science, but I think the science is slightly the science in the meme is slightly wrong from
slightly off. Yeah. Maggie,
I'm gonna go for a D.
Going for a D.
I think a lot of people would find it difficult to even figure out what that is.
All right, I'm not going to argue because I was going to say C, but. Okay, we'll go D, C or D. I was going to go. So, okay, strong D, super. So that was Jazz. Oh, I'm back. Brilliant. Classic meme format. The person in front of the grave here, Schrödinger's cat. So obviously the idea being here, the kind of famous thought experiment by Owen Schrödinger, that essentially you can't know the state of a quantum mechanical system until you do a measurement. So the way that we would describe it is probabilistically. So the cat would be kind of half alive, half dead until we make a measurement, until we open the box and look inside. And the idea here is that you have the cat both out of the grave and inside the grave. There's lots of variations of this, like someone banging on a box and the cat meowing inside and all these kind of things. Thoughts here, Maggie?
This is like so random, but I like it. It's cute.
Now I'm learning. Pick the cuter ones, and then there's more things that can work in your favor. I'm learning. Right. Good.
It made me laugh just because of like the peace sign and stuff, but yeah.
Clara?
Yeah, I mean, I've seen this picture used, like the base picture that it's based on, used a lot. So I like the familiarity I felt as soon as you showed it. I knew what the face behind the cat was looking like. Yeah. Again, I'm overthinking things because they should still be in a box.
Yeah. But, I mean, the cat is in a box on the ground, maybe.
Yeah, but the other one's out of the box.
Okay, all right. I tried.
But it's still a very solid meme.
What are we saying, Clara? In terms of score, a B.
Yeah.
Maggie?
Yeah, I think it's a B.
You're going to allow me a B? Okay, I was going to say A, so we'll go B. That's fair enough. B. Good stuff. All right, where are we back? So we're back to so we've flown through these. 1, 2, 3, 4, 5, 6, 7, 8. Good stuff. So where are we at? And we've covered the science nicely. Clara, you gone niche again. I like it. I like it. I like it. And I very much enjoy the pigeon on the pigeon. It's a very good recent one. So talk us through this one.
Yeah, I'm going to get torn apart for how niche it is again. Often we have the Large Hadron Collider at CERN, and everybody hears about that. And it is an incredible 27-kilometer long particle accelerator that we use to discover the Higgs, amongst other stuff. But it's not the only accelerator that we have at CERN. And also, these accelerators are the pre-accelerators. They feed into the LHC, and the LHC needs them to get to the energies where we're going. So the joke is that the LHC is riding on the work of the other accelerators as well.
Yeah, it is a little bit sad that some of these don't get, like, nowadays the kind of fanfare that they probably should. Like Clara says, these are all, you can't speed things up from 0 to the speed or the energy of the LHC in one machine, because I guess you just can't ramp these magnets fast enough, right? So you need these intermediate sections. And the beautiful thing at CERN, I once did the tour. As you walk backwards kind of along these collider rings, you can walk backwards in time, essentially walking back along all of these collider rings, going right into the older buildings of CERN until you get to this one LINAC, this linear accelerator. And then took me completely by surprise, but makes total sense if I'd have thought about it beforehand. You just come to this red bottle of hydrogen on the wall, because obviously you think of this LHC as smashing these amazing number of protons, but protons are so small that the start of the LHC is essentially just squirt out of a bottle of hydrogen on a wall, which is kind of crazy to think about, all of this activity that goes on from just a couple of squirts of a bottle of hydrogen. So I enjoyed this one. Maggie, thoughts? You're gonna go in on this one for nicheness. We know this.
I had no idea what those acronyms were.
Again, I kind of enjoy the in feeling we've got now in the particle physics about this, but yes.
Yeah, I knew there were other experiments in, like, the Hadron Collider and stuff, but I didn't know those acronyms, so I would have been completely lost with this.
Okay.
But I like the cute picture.
I do. I like it. Gets it nicely across. So there's some good science here. There's relevance of getting those kind of less well explained experiments through as well. The science works nicely because the LHC obviously rests on all of these things. It's a recent meme, so I like that as well, and the subversion. So I would give it, just because of the nicheness, a B. Maggie, what do you think?
I'm going to give it a C.
Okay. Clara? B,
I'm going to
C?
say it's worth an A so that it goes in a B.
All right. I like what you've
Good
done
job.
there. I like what you've done there. Good. Right.
But I also acknowledge it was very niche.
It is very niche, but like I said, I do enjoy a bit of a niche meme. So
I feel a bit cornered as well. I'm like the only astronomer against you two.
I know. Jazz unfortunately couldn't make it, so it is a bit of a tag team here on the old particle physics, but I do not apologize for that. Good. So this is a classic, but I don't know how much science we've got here, Maggie. Talk us through what you were thinking here, or did you just want a pure classic in here?
Yeah, you just said space memes. You didn't mention it had to be science. Like,
I mean, the criteria were not revealed to you beforehand, so that's okay.
This is just facepalm, and it's quite commonly shared. And I think it's from Star Trek, but I've never watched Star Trek. I'm probably like one of the only astronomers that don't watch that kind of thing.
Really? I'm more of a Stargate man, to be honest, which I get ripped apart for.
What's wrong with Stargate?
Exactly. That's what I say. But people are like, oh, Star Trek, you don't take it seriously. But no, it's all about Stargate for me. No, I mean, this is a classic, Clara, right? But I don't know how much science we're getting out of this.
None, but I would definitely share this.
Okay. There's quite a few versions of this with like double face palm and quadruple face palm, where they're like doubled up the hands, which are kind of ones that I prefer. Maggie, what makes you do this the most in your field of research? Maybe you can save a rank here by giving us a little bit more insight.
Okay, so I teach a machine learning course, and some of my students, well, they have to like program self-driving cars, and these self-driving cars have batteries in them. And the students nowadays, they don't know how AA batteries work. They don't know how the plus and the negative end work. And I've told them so many times, but they keep blowing up my cars. And it's just
that will make one face palm. Good. Clara, what makes us do this most in particle physics? I mean, I could name a person, but I'm not going to do. What makes us do this?
Yeah, I won't name any names.
We won't name any names. No, we're no names.
I mean, some of the conspiracy theories I've heard so many times that when somebody brings them up, I'm a little, sometimes I think, because I think there's so much cool, interesting science happening at CERN, and I sometimes feel very disappointed that that's what people hear about, and they miss out on the actual really exciting stuff that we're doing.
Yeah. No hell portals, no nothing exciting like this. Just solid science, interesting stuff as it is.
People think we're building Stargates, and as two massive Stargate nerds, if we were building them, they would already know. We would have filmed it.
Yes, exactly.
There would be selfies in front of it, and we'd have gone on an adventure. So
Correct.
Sadly, we don't have one.
Maybe you should tell people that you're building Stargate so they actually fund you.
Yeah. Our next collider will be
we'll be the hell portal. If you just fund us, we can build it. Right, exactly.
You want one?
What is it? The UAC? Is that the Doom ones who make all the hell portals? We'll bring them in on our next experiment. Clara, what we saying for a score here?
I mean, I might give it a C because it is a very solid meme, but it doesn't have any science. But to be fair, my criteria was that if I would share it, it would be an S, and I have shared this one, so.
All right, so we draw it up 1. How about a B then? Is that fair? Yeah. Drag it up 1.
Well, okay. Yeah, you can quote me as a B. I don't know what Maggie.
Maggie, what are you thinking?
B as well.
B. I was gonna go.
Shared it.
I was gonna go C just because if you'd have put like a link to some science there, I would have probably given you an A, but because there's not much science there, I was going to go C, but I'm happy with B. People are voting for B. Good stuff. Right, Jasmine, what did Jasmine bring us next? That's Jasmine's last one. So, Maggie, talk us through this one. Probably fairly self-explanatory.
Yeah, so the moon orbits around the Earth orbits around the sun, right? So occasionally you'll have the top one. Other times you'll have the middle one, but you should never get the sun between the moon.
Yeah. So we've got a nice setup here in terms of the science guests showing you what a lunar eclipse is, showing you what a solar eclipse is, and then a nice little joke at the end, which has kind of the same suffix of ips on the end for apocalypse. Clara, thoughts?
Yeah, I mean, I'm a big fan of this one. This is a Katie Mack meme. I think it originally came in emoji format, so. Yeah, I think it's a very solid joke.
All right. So what are you thinking in terms of a score here?
I would give this one an S tier because I think it's very good science. Everyone can understand it.
Maggie?
I would give it an A.
You're going to give it an A. I was going to give it an A as well. So I think we're just below S, but I think we all enjoy this one. So solid science, nice little joke at the end. Correct science as well. I think that's a pretty solid one. Good. I'm back. So where are we at? Oh, yes. When I said don't mention names, we are going to mention one name. So there's a very common line. I forget this gentleman's name from PBS Spacetime. I believe you know him, Clara. Do you know the name of the...
Yeah, it's Matt.
Matt, that's right. So Matt from PBS Spacetime. I think he has a little bit of a penchant for saying, actually, quantum mechanics forbids this. Now, we have a very famous science communicator who doesn't like people talking about particles that have not been discovered yet, that maybe particle physicists think can solve some of the problems that are out there, gravitons or maybe supersymmetric particles or things that are potentially well-grounded with the theorists, but we do not know exist as yet. And they get a little bit upset that we talk about these so frequently. So, Clara, any thoughts?
I'm kind of trying to not talk about.
Shall we skip because it mentions a person in particular? Maybe we don't.
As long as we're kind, I think we should be very professional about our colleagues who have differing opinions.
Of course.
I think there's no harm in light memes, and I think this is a very friendly meme. So
I didn't think this went in too hard. Like,
no.
It's not too mean. It's just, this person has a slightly contrary view to some other particle physics, which is fine. They're a qualified person who can have their opinion. Thoughts on a score?
Maybe a C. Like, I think it's a. Yeah, I personally stay away from it, but the person mentioned in here is very well known, and so and I think it's a light joke at the fact that they don't agree with
it's not too
certain
savage.
Particles existing. Yeah, so I don't think it's harsh.
All right, I'm happy with the C. Maggie, thoughts?
Does everyone know them?
They do.
I feel like physics. Again, like yeah.
So maybe I've fallen into the niche trap here.
I'm gonna go for a D because I don't get it.
Okay, I'm happy with a holding a strong C for this. Okay, good stuff. Right, so we've got one more round through before we are going to announce our champions. So where are we at? So Clara, you are back with a final shot. So along the same idea, I like this one. Talk us through the science here.
Yeah, so we accelerate protons to very high energies in the LHC to be able to study the building blocks of the universe, but it's nowhere near as high energy as the ultra high cosmic rays that hit our planet. So the collisions that we're doing are very controlled, and we need to do them in an environment where we can put a detector around that, but nature does it much higher. So this is making fun of the fact of look at what they need to mimic a fraction of our power.
And we never know where these damn things are going to land, right? So to get the huge luminosities that we want as well, lots and lots of collisions, we need to build these fantastic machines, because unfortunately as powerful as these ultra high cosmic rays are, we never know where the damn things are going to land or how frequently they're going to land. So I like this one. Very common meme format. A bit of people like this kind of. Is this anime? I'm going to get ripped to shreds for not knowing what anime or manga.
I think that's Wolverine at the front in the yellow, isn't it?
Is it Wolverine?
Is it Marvel?
We're going to get killed for this.
Yeah.
Very common. I've seen it a lot anyway. Maggie, thoughts?
Yeah,
Got a little bit of space in here. So space. Yeah. Crossover with particle physics. Can we get on board? The Predator handshake here. Can we do that or we no?
I quite like it. It's good? Okay.
What are we talking in terms of score?
For me, it's a B.
B. Okay. I'm feeling an A. So Clara, you got a.
I'm gonna give myself an A. I really like this one, and I think it bridges the divide. And also, someone can correct us in the comments. Of exactly where the meme came from.
Please tell me about modern pop culture, because I'm totally lost on this one, whatever it is. Although I push myself on knowing this quite well, I'm lost. So yes, please. Again, second pinned comment is what is this? So,
honestly, I was gonna say Homer Simpson, and then I was like, oh, but his hair is black on here.
It's like the opposite, and it's much more. Doesn't he only have two strands? Or anyway.
Yeah. Anyway, I think we should have also had the Captain America. I understood that reference.
There we go.
Show up.
That's good. That's for part 2. That's for next time for the follow up. Good stuff. What did we say? Did we go? We got a strong A, didn't we?
A.
All right. So at the moment, we still got one S tier who's leading the way. So where are we at now? So we're back to Maggie. Maggie, no, you're out. You run out. So we're back to me. So where are we? So I got this one. So physics, everyone loves physics. Everyone knows that physics impacts their life. It's a very fascinating topic. However, sometimes it becomes very difficult to get into some of the weeds of things, particularly particle physics. You need to learn about relativity, which is not everyday experience, deals with very quickly moving things. You have to deal with quantum stuff, which again is very, very small things, not in our common real world experience. So it's very mathematical, can be difficult to understand. Same with relativity. Other hard things that you need to learn about before you can get a full grasp on particle physics. So this is just making the point that learning physics is incredibly complicated. So everyone loves it, everyone enjoys it. We got the chap coming home here, but he's got these horrible things waiting for him. So Maggie, thoughts?
It's quite cute. And I also think like not just physicists think that like physics is easy, like just like a lot of general people do, because I get a lot of like crazy people who like send me emails or physical mail with their like big theories saying like, look, I've proved like all gravity is wrong or something like crazy, and like you get pages and pages of calculations, and I'm like, what?
Clara, do you still get some of them? I remember a particular gentleman when I was at CERN who used to send things through about the Higgs boson being a beryllium atom or something, and
he doesn't email anymore.
Does he not?
No, and honestly, as like interesting as his theories were, I actually missed the emails, and I hope he's doing okay.
He seemed like quite a sweet, like it was never like, you know, F you losers or whatever. It was always like, please, venerable sir. Like it was like one of those
very formal.
Yeah, one of those phishing emails where they want your bank account details. So it was always like, dear venerable particle physicist, Dr. So-and-so, I would like to impress upon you my amazing theory that I've spent ages doing, that, you know, the Higgs boson is a beryllium atom or something. And it was just crazy stuff, but it seemed like a harmless kook rather than a, you know, someone who was particularly dangerous. So yeah, I do kind of miss those emails.
I'm won over by the politeness. No, people do still send me their theories, and the problem is that often they're quite long, and I don't have enough time to read through them and also do my day job. So I don't want to be the person that dismisses, and then it turns out there is someone who has. But also, there is a foundation of physics you have to learn and study before you can then. It's the same way I always think of Picasso, who we always remember the sort of style of painting of Picasso, but he was classically trained and could do a very classical painting and then broke the rules. So you have to learn the rules and master them before you can break them. And so, there's a whole lot of foundational science that you have to learn before you can invent new theories.
And it is tough, right? Because we want to get people really excited about particle physics, and sometimes there's almost so many things you have to teach someone before you can explain something. Sometimes that can be a little bit daunting, a little bit difficult. But
also, it's very frustrating as a student when you're learning science and you think you've got something, and then you go into the next class and they say, "Oh, well, everything we told you in the last lecture was wrong."
or when you think you've thought up something like mind-bogglingly amazing, and it's always been done by like some Hungarian scientist in, you know, his basement in the 1840s or something. So like, you know, it's not
quite the same, but I invented noise cancelling headphones and was very excited about this, and then came back from a summer holiday to my university, and this guy was like, "I've got these amazing new headphones, they cancel all of their surrounding sound." And I said, "Oh well, I was about 3 years too late."
that would have been the $1 billion.
Yeah, turns out they already existed. So
what we thinking here, Clara?
So I do really like it, and again, it's a very classical meme format, and everything we've just discussed, you know, I agree with the fact that it is harder than you think, but also there's a part of me that I don't want people to feel put off by thinking that it's so hard it's not possible. So there's a nice balance where you have to do the work, but it's not out of anyone's reach to learn this stuff. So but I think it's funny. I think it's
that's why I kind of kept it to last, actually, because I, like you, exactly. I think anyone can learn this stuff, or at least anyone can get hold of the high level ideas if they don't have the mathematical background. So I was slightly torn on this. Want to give us a grade?
Maybe I would give it a C. I think it's a good one, but yeah, that last point would maybe pull me back. Maybe I'm happy if it moves up to a B.
All right. So between B and C. Maggie, thoughts?
I'm going to go
she
for a
just
C
wants
as
to find
well.
reasons to be savage about it. Good. C. All right, I'm happy for it to hold a C. If only for the no, we believe everyone can learn this stuff. So maybe give slightly, although I like it and it is difficult. I like the message that anyone can do it. Good stuff. Clara, your final one. So we got two left. So talk us through what we're dealing with here.
I mean, the World Wide Web was invented at CERN, and it was freely given away. We didn't patent it, and we like to remind people that it was invented at CERN, and it was a gift to the world.
We do enjoy telling people this. Maggie, were you aware of this?
I was aware of this.
Beautiful gift that we offered
people that as well. Like, I'm like, physicists invented the internet. You know that, right? Yeah, I like it.
Good. Yeah, I really like this as well. I like the just because it makes it really relatable for people as well, right? That's like, why does this field of particle physics have such an impact on my life? Well, here's the World Wide Web. So if you're not interested in smashing particles together, you're not interested in all of that, you don't want to know about supersymmetry or what might be going on at the TeV scale or whatever's going on with the next collider, well, every single day you use this World Wide Web to share your memes or check for information or log into whatever it might be. So I think this is very relatable. I like that it gets that science across. I like that it gets that impact of particle physics across as well. So I'm a big fan of this. I like, and I just like the kind of rugged coalface Sylvester Stallone in there as well, giving it to like a very happy, proud society who's kind of just accepting it for free. So I like that a lot. I'm thinking an A. Maggie, what are we thinking?
I think it's a solid A.
Solid A. So Clara, you got a chance. I hear a solid A there. So maybe
I'm happy with a solid A.
A solid A.
I think it's not it's not quite S, but I think solid A.
Okay, so we're going to go with a solid A. Right, final one. This is my final one. So what did I bring? Maybe this suffers from the same problem as last time then. This is kind of why I left them to the end. So maybe physics will improve my life. Happiness. I learned so many things. Knowledge of physics helped me. So obviously physics is, maybe this, like I said, suffers from the same problem. So learning physics, you learn about all these amazing things. Fantastic. I feel really, really smart. And then you get into these same problems again of quantum field theory and gauge field theory and all sorts of things. And then you realize how much you don't know. And there's just learning throughout your entire life. I think nowadays nobody can learn kind of all of physics, which is why we specialize into certain areas, space and quantum and particle physics, as we're talking about today. So thoughts on this, Clara? Maybe suffers from the same problem as the last one?
I don't think it does, because I think it's more of an existential, you know, the more that you learn, the more you realize. Well, like, for example, as Maggie was saying earlier, that a lot of the galaxies or stars we see out in the sky are already extinguished. And there are other things that you learn about when you get more knowledge of physics that can give you a bit of existential dread, like how will the universe end and things like that. But
I want people to be happy learning their gauge field theory or whatever, right? I know that is probably the wrong. Nobody's really happy when they have to, you know, do all of that. But you know, I don't know. What do you think?
And I don't think it's necessarily that you're unhappy knowing that you don't know loads of things, because like there was a point in my career that I just realized, wow, there's so much that we don't know. But that doesn't make me unhappy. It makes me feel like that's good. There's a lot of work to be done.
Yeah. I'll always be in business. So it's gonna be
I'll
okay,
always be employed.
Always be employed. Always be in business. Exactly. Good. All right then. So Maggie, give us a score for this one.
It's a C for me.
It's a C for you, Clara.
Yeah, I mean, I'm happy with a C because I don't think it has the same problem as the last one.
Right.
But then we don't want too much existential dread.
Got enough. I'm over 40 now, so we can do with that. We can do with that. So, all right, I'm happy for that to hold a strong C. So it looks like, off the back of our discussion, obviously, you know, this is entirely subjective. This is our opinion on this particular day. So if anyone has their own particular favorite space or particle physics meme, you can drop them in the comments below or mention them in the comments below. Maybe we'll follow up and do another one. But this is not a hard and fast solution. But our S tier meme is going to be Jasmine's, which she shared from afar with love, of this one. So the flat Earth. So Maggie, tell us again why this is such a good meme, just for people before we finish off. Why is this our winner? Why is this our only S tier meme?
It's because the Earth is
Is it because it's
space?
Is it because it's space? Is that the only reason?
Scientifically, it's so correct, right? No. It brings awareness of how silly it is to think that we're special and the Earth is flat, whereas all the other planets we know of around. And yeah.
Clara, thoughts? Why is this our winner? Why is this the best?
Yeah, I mean, I think Maggie explained it very well. It really sets it in context with the other planets that we've observed, and that it's not, the Earth is not flat.
I feel like this is one of the ones where you could either, why I think this one's so powerful is because you could either spend like 20 hours arguing with someone and talking about, NASA said this, or we went up in a spaceship and it looks like this, or they did this laser experiment, or you could just show them this, and it's almost the absurdity is all there in just one argument. The
problem is I have spoken to people that could also argue this one away, but some people are very tenacious.
Yeah, maybe when you get to that level though, there's just no winning whatsoever though. Simple, colorful, not many words. I think it just ticks all the boxes. So this is our winner today. So guys, thank you. Please.
Oh no, sorry, I didn't. I was just going to say, I also quite like, it's quite a 90s TV show phrase, like, well, this is awkward. So I think that gives it a nice so
for those 90s kids,
Yeah.
One thing before we finish, do we think, and Maggie, I'll come to you for this, do we think space has an inherent advantage in these memes and in these pictures, because they have so many beautiful pictures that they can just share all the time, straight off the bat? Thinking about JWST now, do you think space has a kind of inbuilt advantage?
Maybe, but also it's a bit biased. You two are particle physicists.
maybe if I bring up whatever I got some like spares that I had, so maybe if I bring up this, which probably makes the point. So space has all these beautiful pictures, these JWST deep fields and all this kind of thing. And us particle physicists, we're kind of happy with ugly, Comic Sans diagrams and horrible text. So I was just wondering, Clara, do you think that space gets, have they got an advantage over us with the beautiful pictures that they can just kind of go have some of that?
I am very envious of the beautiful pictures. I mean, they've got their share of nice diagrams and scientific plots as well, but yeah, it's really helpful when you can just
say look out there and you can see what's going on. Although I will fire back with this.
Yeah, I was gonna say, but you can come visit our detectors in real life, and we don't have to fire them into a planet when we're done with them. So that was pretty sad with Cassini.
Coming out swinging. I like it. Good. All right. So our winner today, and you are welcome to give your opinion down in the comment section, is the flat Earth meme. Maybe we'll do this again. If you have your own, like I say, pop them down, describe them down in the comment section, and maybe we'll do this again. Guys, thank you so much for taking the time to go through this with me today. I really, really enjoyed it. I think we got some good science out, and I really thought it was a lot of fun. Before we go, because both of you run your own brilliant social media channels, do you want to point anyone to those and the work that you're doing? So Clara, maybe if I come to you first, because I know you have your brilliant Instagram and TikTok channels especially, and some other things. So do you want to tell people about the kind of things that you're doing?
Yeah, thanks. So you can find me pretty much anywhere as Particle Clara, and I share behind the scenes at CERN videos. If you want to see our detectors, then I go underground and walk around them and explain the results that are coming out of CERN, and I'm happy to chat about anything particle physics or even astro related, but that's not my expertise. I love I'm a fan of the astro results, but mostly I talk about particle physics.
We do like them when they're related to like cosmology and the overlap and neutrinos and all this kind of thing. So there's a bigger overlap than people think. But yeah, these are really brilliant channels. You can get up-to-date news from on the ground in CERN. See the colliders live. Very much recommended. I'll put all the links down in the description. Maggie, as well, you have a fantastic YouTube channel as well. Do you want to tell us about the work that you're doing?
Yeah, I'm Space Mog on YouTube and Instagram and occasionally TikTok and Twitter.
Do you share much? Do you share much? Do you share enough?
Maybe not. But YouTube, I'm there like weekly. Videos on space and astronomy mostly.
Awesome stuff. Awesome stuff. Brilliant. Again, all of those links will be down in the description. Guys, thank you so much again. I really, really appreciate it. And next time something comes up that's in both our wheelhouses, we should get together and discuss it again. Thanks very much.
Sounds great.
Thank you.
Pleasure. I want to know what you think, because you're the scholars of enlightenment that I do this for. So please take a moment, if you wish, to let me know down in the comment section. And if you like this video, please consider leaving a like, subscribing, setting up notifications, and sharing this video more widely. I can't tell you how much these simple actions help me out and how much I'd appreciate it. Thanks for watching. Thanks for being scientific. Thanks for being bad.